Good morning, ladies and gentlemen. Now I'd like to continue my video series about the usefulness of the Notebook Assistant in developing Mathematica projects. Just remind you, in the first video I considered an elementary problem using plot solving equations with a high school problem, and after that we considered the dynamic visualization problem. In addition, I recommended you to see the websites in which Stephen Wolfram introduces Mathematica 14.3 and the introduction also by Stephen Wolfram of the Notebook Assistant and the website of the Notebook Assistant as well. Now, in this video, I'd like to consider some other problems, complete projects, starting with importing data from Excel and fitting a model to the dataset, and we try to fit the differential equation to the model, and after that maybe in the next video we consider more examples in various fields. Now let's consider a complex modeling project, starting from the data saved in Excel up to an ODE model fitting to the dataset. The problem is the following. The Excel file motion XLSX contains data of a motion, time, position structure, and I would like to investigate this dataset in Mathematica. Import, visualize, smooth and fit a model to the data and find an ODE model fitting to the data if possible. I try to write the application with the help of the Notebook Assistant. Here is one possible discussion. Let's start. How can I import the motion? I get a general answer because I didn't say where my file is, so I wrote that the file is in the notebook directory. How can I set it as a default folder? Set directory, notebook directory, data, import, data is equal to import, etc., etc. And then now running the code, it works. How to visualize the data? The answer is simple. We have several possibilities, either list line plot or list plot is recommended by the Notebook Assistant. I will use the list plot and the result is here. We can see that the data set is pretty noisy. How can I smoothen it? For smoothing there are several possibilities. The moving average is one of the simplest ones, and that's what the Notebook Assistant also recommends. Run the code I got, and we can see that the smoothed data set, original data are also plotted, and it's really good. We can see, and we have a conjecture, that the data looks as a superposition of sinusoidal oscillations with different frequency. How can I fit such a? The Notebook Assistant gives me the steps. Define the model, use nonlinear model fit, and do the fitting. Let's try to run what is recommended. We can see that the answer is not correct. There must be some syntactical error in it. I called the attention to the Notebook Assistant. I got something more, and then I try to run the corrected code. And now it's fine. The code is correct actually. The fitting is not the best. That's why I try to improve it. I said it doesn't fit correctly. Maybe with other initial values. Of course, I got other initial values, ran the code, and we can find that it's pretty much the same. It's not better. Certainly the fitting model is not correct. I recommend it to include one more trigonometrical member. It's done. There is another trigonometrical member in the fitting model, and then running the code, I got it, and it's pretty good, so I am really satisfied. What about the description of the model in differential equations? I write something about it to the notebook assistant. Motion looks an oscillation with external periodic force. How can I fit a differential equation? What is the answer? That's important. The first sentence is very important. Fitting a differential equation to data can be more complex than fitting a simple algebraic model, but certainly possible using the parametric ND-SOLVE value function in conjunction with optimization techniques like find-fit. Now first I have to define the differential equation. It's typically a second-order linear oscillation equation with external force. I use it with parametric ND-SOLVE and fit the model. That's the recommended code. Now let's try to run it. Oops, find-fit doesn't work. Something is wrong. Assume that I don't know what the reason is. Again, I reply that I got it, and I wrote the error message. I got a new code. It doesn't work either, and I said that I replied again that fit function and find fit are still wrong. Please correct it. I got a new code, and the key changes are emphasized at the end. But at the end, I realized that the errors in the codes are really very fine, so my Mathematica experience, my Mathematica knowledge will be much faster than continuing the discussion. So instead of further discussion, I use my Mathematica knowledge and then I finalize the project. The differential equation is correct. This part is wrong. Defining the model is wrong because somehow a map with the time is not needed and it's not appropriate in this situation. Now the find fit code, the find fit statement is also wrong because instead of the independent variable the parameters appear again. And then that's why it doesn't work. Instead I wrote the code, actually I wrote the independent variable and then the find fit works, but numerically it's not correct because the conversion is not correct after 100 iterations. So from this moment, that's my work, how to improve the approximation, how to improve the fitting. But anyway, finally the plot is correct, but from the plot you can see that the fitting is really not. So now, from this moment, using my deeper Mathematica experience, I need a better finding and a better code because I realized that the last code is pretty slow. I defined a new model, including a second external force, external function. Parametric ND-SOLVE works correctly. I checked it. That line fastens the code very much. That's very important. It is found in the documentation center. After that, we can write the fitting. It's done, it's correct. The fitting solution is here, and you can see that this is perfect. To find the initial predictions for the parameters, it's very good idea to do some experimental work using the manipulate. But for doing that, I needed the general form of the symbolic solutions of the differential equation, so I asked again about it the notebook assistant. And after that, this is the final version using the manipulate. I can play with the parameters, trying to fit the curve to the data set and finding a good initial prediction for the parameters. I can run the fit and then we can find the final fitting, and now we fitted the differential equation to our dataset. So we could see finally that this is a really complex model with very complicated programming and mathematical problems. That's why we cannot expect that the notebook assistant solves it immediately, but a good communication with the notebook assistant helps a lot in completing such a project. We will continue with other more interesting problems. Hopefully I helped again. Thank you very much for watching me.